Welcome to solverfy.
So here we have a circuit and a combination of capacitors. So let's say this capacitor is 10 picofarad, and we know that 1 picofarad is 10 to the power minus 12 farad. So there is another capacitor of 20 picofarad capacity, and there is a resistor over here that is of 25 ohm, and there is yet another capacitor of 15 picofarad capacity. So here we have a switch as well. Let's say this is a switch, and this switch is initially open, and each capacitor in this circuit observed here that has a charge of 3.5 nanocoulomb initially, and we know that 1 nanocoulomb is 10 to the power minus 9 coulomb. So each of the capacitor that has 3.5 nanocoulomb, this also has 3.5 nanocoulomb. So now the switch is closed, and after this we need to figure out the current in the circuit. Let us say I is the current, and we need to find out the current in the circuit when the capacitors have lost. So I will be what? When all the capacitors have dissipated, or we can say lost, 80% of the initial energy. So in order to progress ahead, we first find out the equivalent capacity of this given network here, and these are in series. So their equivalent capacity will be 1 by C, that is equal to 1 by 15 plus 1 by 20 plus 1 by 10. So from here, if we simplify, we get the value of C coming out to be 4.62 picofarad. And the initial charge, let us say, we talk about Q naught. That initial charge is given as 3.5 nanocoulomb. So nanocoulomb, we use the factor 10 to the power minus 9 coulomb. And the resistance is also given to us. It's of 25 ohm. So we can find out the energy of the capacitor. So energy of the capacitor, that's given by the expression E naught e to the power minus 2t by RC. And we have 80% of this energy. That means 80%, yeah, 80% of energy is lost. That means only 20% is remaining. So we need to take 0.2 times of the initial energy. Initial energy is the maximum energy. So this should be equated to what energy we have at this time t. So E naught e to the power minus 2t by RC. So from here we can cut this E naught and get the value of e to the power minus t by RC as root of 0.2. And we know the expression of current for the capacitor which is discharging. So it will be I equals to I naught e to the power minus t by RC. So we put the value of e to the power minus t by RC as root of 0.2, but we need to even get this value of I naught, and I naught will be obtained with ease, that is the initial charge divided by the RC value, because anyways we are going to get this equation from the discharging of capacitor Q equals Q naught e to the power minus t by RC. So we get this value of I naught, and let's put in this equation. So we get current as initial charge, that is 3.5 nanocoulomb, divided by the resistance times the net capacitance. This C is the net capacity, and that we figured out as 4.62 picofarad, so 10 to the power minus 12, and root of 0.2. So simplifying this gives us the current in the circuit at this instance, that is 13.6 amperes. So this is the current that is flowing in the circuit at the instant. At the instant S is closed. So what is S? S is the switch over here in the circuit.